Welcome back to Dr. Mohanty's Masterclass. Today we will explore a niche, yet fundamental aspect of analytical science, something that quietly supports every accurate result we generate. From reference to result, the journey that defines accuracy often begins at a place we do not always examine closely. Let us understand that foundation. When we think of accuracy, we often think of instruments, methods, or even the analyst. But behind all these, there is something more fundamental. Every result we generate ultimately depends on the reference we use. So the natural question is, what exactly is a reference material? A reference material or RM is a substance with a known property value which is used for calibration, validation and quality control. It is the starting point of all measurement. Without a reliable reference, even a sophisticated instrument can produce unreliable data. On the other hand, a certified reference material or CRM goes a step further. Its value is not just known, it is scientifically established with traceability, defined uncertainty and certification. This makes it a reliable and defensible benchmark, particularly in applications where confidence in measurement is essential. This is especially relevant in regulated and high precision analytical work. Now let us understand the basic difference between RM and CRM. RM may be sufficient for routine work, but CRM becomes essential when accuracy must be traceable and defensible. The difference is not just the technical, it is about the level of confidence required in the final result. Now let us look at two other commonly used terms, reference standard or RS and certified reference standard or CRS. RS are working standards used within laboratories. They are internally qualified. CRS such as USP, IP, EP, BP, JP standards are official standards used for compliance. These are highly characterized but designed for specific analytical methods. CRS are often used as reference points for qualifying working standards within laboratories. To understand reference standards and reference materials more clearly, we must look at two frameworks. One is traceability linked to global measurement standards. The other is regulatory compliance linked to pharmacopoeial requirements. These are complementary frameworks serving different scientific purposes. One framework strengthens measurement traceability and the other ensures regulatory conformity. So a CRM gives you measurement confidence through traceability and a CRS gives you regulatory acceptance. They serve different roles and are not interchangeable. Selection must always be based on the intended application and level of confidence required. The key is fitness for purpose. You don't always need the highest level, but you must choose the right standard for the right application. Scientific judgment lies in choosing what is appropriate, not simply what is highest. For example, CRM may be preferred for validation and critical measurements, while CRS may be used for pharmacopoeial methods and RS for routine quality control activities. In practical laboratory work, we often encounter compounds where pharmacopoeial standards are not available, such as impurities, peptides, or specialized molecules. In such cases, reference materials are developed and characterized in-house, using analytical techniques to establish identity and suitability. Such characterization may include chromatographic, spectroscopic, and other orthogonal analytical approaches. This becomes especially important in emerging and niche molecules where official standards may not yet exist. Where standards are available, qualification is done accordingly. The key remains fitness for purpose with a sound scientific basis. Reference materials are not limited to one industry. They play a critical role across pharmaceuticals, research, environmental testing, food analysis, calibration laboratories, and increasingly in advanced sectors such as semiconductors and high purity materials where even trace level variations can significantly impact performance. Wherever accurate measurement matters, reference materials become essential. Many times we question instruments or analysis, but rarely the reference itself. Yet, this is often where the hidden risk lies. Sometimes the problem is not the analysis itself, but in the reference used to establish the analysis. A poor reference material can lead to improper qualification, out of specification results, audit observations, and ultimately wrong decisions. Now let us talk about one of the most important aspects of a CRM, traceability. Traceability connects your result to a global chain of standards, ensuring reliability, comparability, and acceptance worldwide. Traceability not only improves comparability, it also strengthens confidence, consistency, and data integrity. It creates continuity and confidence across laboratories and over time. So, to recap once more, accuracy doesn't begin in the instrument. It begins with the reference you choose. At Advent, over the years, we have been quietly strengthening our capabilities in reference materials, particularly in characterization, traceability, and analytical reliability. In the next session, we'll explore how these principles are translated into practical solutions aligned with the growing needs of modern analytical science. In the next session, we move from understanding to application. Till then, stay tuned, stay focused, and keep exploring the wonderful world of chemistry. Thank you very much.